Chapter 4: Forces in the Laws of Motion. First thing, let's get a historical perspective on some of this stuff. Back in 400 BC, we had a very smart individual named Aristotle. Aristotle said there's two types of motion. There's natural motion, in which things like heavy things fall and light things rise, like rocks and water and things fall. Light things rise, such as smoke and birds. Then there's violent motion, and that's imposed motion. So something like you were pushing a cart, that would be called a violent motion. Then there were the Dark Ages, in which it seems like no learning actually happened. And Galileo came along in the Renaissance. Galileo figured out that force is needed for motion. He did some experiments, and he was arrested by his government. He was responsible for figuring out free fall, acceleration, and a lot of other really important stuff in the astronomy world especially, but a lot of scientific experiments. The government was not so keen on this, and he was put on house arrest. Then we have this other gentleman down here, Mr. Sir Isaac Newton. He figured out the three laws of motion. He did this all by age 24. He also invented calculus in order to figure out some of his ideas and explained gravity. Now, I hate to break it to you, but if you thought that the apple falling on Newton's head gave him the idea about gravity, that's highly unlikely. He probably was just using that idea as an example. So we need to ask ourselves, what is a force? A force is a push or a pull that causes an object to accelerate. There are two types of forces. We have contact force, and that is a force between two objects that are in contact. And there are field forces, forces that exist even though objects are not in contact. Three big keen examples on field forces would be gravity, electricity, and magnetism. You do not need to be in contact with the ground, for example, for gravity to act on you. We're going to make force diagrams. Now, the thing about a force diagram is you have the objects in question, so Bob and the box, and then you would draw arrows emanating from the inside of it going in all directions here. So maybe that's some sort of resistance force on Bob, and this is some sort of resistance force on the box. And then I have an arrow for the action force of Bob on the box, and then some sort of force that allows Bob to go forward. You'll notice I'm drawing the arrows coming out of the center of the object. Perhaps this is the force of the ground on each of Bob and the box. And this is the force of gravity acting on the box and the force of gravity acting on Bob. As I said, I like to have the arrows coming out of the center of the body. The other kind of diagram we draw is a free body diagram. In a free body, you only have the one thing in question. So if this was just the box from the previous question, you'd have force of gravity, force of the ground, his action force to the right, and resistance forces to the left. And that's a free body. You don't have everything, just the one thing. And then R2-D2 gives us some homework questions to look at. And these questions are largely just making drawings right. And then I remember this one question that has three parts. Name forces that cause things to start moving. Well, anything that you have where you are pushing or pulling on something to make it move, that's one of your action forces. The second thing, name three forces that cause things to stop moving. Again, things like brakes on a car, friction on a box, things of that nature. And then things that cause direction. I like to think of sports here. If your foot applies a force to a ball that's moving towards you and then you kick it away from you, or a baseball hitting a bat, the bat applies a force to the ball causing it to change directions.